Hello all, good morning, good evening, and good afternoon. My name is Yuvraj Rangraj. I'm the program manager for OptiStack Interface, and I work in OptiStack team. Today, I'm going to briefly talk about the panel migrations or the panel removal, which has been in play as part of the corporate priority. So I'm going to talk about the thermal card migration and other migration which have been part of 2022.3 release, and quickly go over the OptiStack solver enhancements specifically for .3 and also for .2 release versions. And I will also touch base on the new curve editor in HM for 2022.3. Without any further delay, let me start with my content for OptiStack interface. One of the primary goal as part of .3 release was to migrate the thermal cards, which have been mapped to the group entity in the past. So if you see here, what I'm highlighting here is the CHPDYE, which are the boundary elements defined as part of the thermal loads, and also the conv and pconv respectively. All these three cards has been migrated to appropriate HM entities, like CHPDY is migrated to set segment, and conv is migrated as a load now, and pconv has migrated to property. Earlier in the previous release, or even before that, all these three cards were clubbed together in a group entity, and setting up the thermal analysis for OptiStack was a tedious task. And now with this improved enhancement, user can set up the thermal analysis for OptiStack in a quick, easy steps. What is the motivation behind this is so we have, as part of the migration, we can create multiple cards from a single GUI for convection and heat flux loads. And predominantly, we do allow the edge selections or the thermal boundary definition, that is the CHPDY elements on the element edges in case of 2Ds. And you could also create individual edges on individual elements. So CHPDY can be defined on individual elements as well based on the selected edges. Earlier, we never had these functionalities available as part of the panel, and now these has been exposed and enhanced as part of the new workflow. A quick demo on the thermal setup. You could access the thermal analysis ribbons from the analyze ribbon in case of convection. So we bring up the entity editor where we create the type as convection, and user can create the element set. In this case, it's a surf where you could define by edges or faces for the solid elements. In this case, I'm selecting an edge of a 2D element. So I can select the edge, and I can create the CHPDY on the edges, and I can access the pick on V, which is a property. Either I can select from the list, or I can also create from the same GUI. And I can also point to an ambient temperature node, which is the TA1 field from the graphic area. So once I'm done with creation, you could see the convection load is listing in the model browser, and you could go to the dedicated view, the loads view, where you could also access the created convection load in this case. And we could also support a review of these elements. You could review the elements which are involved in the CHPDY thermal boundary definition. And similarly, we also enhance the heat flux load, where you could define the QBDY1 on the selected CHPDY elements. Either you could select a new existing surface, or you could select a new, create a new surface from the entity editor. So once I'm done with the creation, when I export it out, you could see the respective area codes getting written out appropriately based on the CHPDY definition created on the 2D element edges. That's pretty much on the thermal card migration. In continuation with the migration, I want to emphasize one important point here is the conv definition, or the CHPDY definition. So what we saw in the previous demo is more of the nest and convention way of defining it. Now in OptiStack, we have a new way of defining the convection, which is called the convg, which is a single card which allows the definition to define the applying region of the convection load, and also the ambient temperature, everything in a single card. Compared to the traditional way of doing, which is the national compatible way of doing, where it involves multiple solver cards to define the convection definition. So I want to emphasize here that the recommendation from the OptiStack is to use the convg for the convection setup. Though we have enhanced the migration in .3, still going forward, I would recommend to use the convg setup, which is already supported in the hypermesh interface for OptiStack. This is just a overview of how the convg card looks like. So all the options are defined in one single card here. And next is as part of the panel migration, we have migrated OSmooth, which was there from the post panel. OSmooth basically used for design interpretation post optimization run in OptiStack. So the controller can be accessed from the optimized ribbon with the OSmooth option. So this is the new controller option where we can define the options which were there pretty much from the panels. All these options are exposed in the controller option here. And they have also, the controller also have a nice way of filtering options based on the output and the geometry type, also the design interpretation type as well. And gauge panel migration. So gauge was one of the panel where we didn't had the annotator support as well. So predominantly user have to use the panel to create the gauge setup for optimization. Now, as part of .3 release, we have migrated the gauge panel setup to the controller workflow. A quick demo on it. The gauge can be accessed from the optimized ribbon from the gauge ribbon here. So we pretty much have all the options which were existing in the panel, and creation is much simpler in terms of setting up the gauge from the controller over here. So user can select the initial value from the property, or you could input the value, and also you could define the lower bound and upper bound based on a real value or a percentage. And you could also associate discrete design variable as well. So all these options are exposed in one single GUI. In this case, I select a list of properties from the property list browser. So on creation of the gauge here, we do create the design variables and the associated DVPRL relationship variables as well in the background, which is pretty much the same way of creating from the panel. And you could access the optimization view from the optimize button here, and which brings up the optimization view, and where you could see all the optimization related cards listed over here in the browser. And another migration which happened in .3 is we have migrated the mass panel. So this is the list of elements which we show up in the mass panel. These are the element types which are mapped to the mass configuration. Now these types has been segregated and appropriately distributed among these ribbons, what is highlighted here. Like masses in this case will have a context where you could define the mass type, select the mass type and select the node to create the mass elements. And similarly, the CLS and other configurations has been distributed among these ribbons, like CLS goes to the springs and the gaps goes to the gap. And acoustics like the CAA BSF acoustic element goes to the acoustics, and CFast and CWell goes to the bonds ribbon here. So similarly, when you create on these ribbons, you'll have a similar context to what has been shown for mass here. Another enhancement is to remove the control cards from the panel. So now control cards can be accessed directly from the browser. Having said that, there's an iterative enhancement going on here. So to access this list of control cards, you need the card to exist in the session. So in the card view, you could right click and select all these options. So by chance, if you don't have a card at all, you could create the basic cards like the case control output and the param cards. So once we have the cards created, you could go to the card preview and then see the list of cards. And also you could do a quick find of whichever card you want to create as part of the control cards, which takes you again to the control cards section, and then right click here, you have access to other control cards listed, which used to be listed in the control card panel. That's pretty much on the migration part. But part of the migration, we did achieve a similar workflow or the improved workflow with the equivalent options via through the controller or through the ribbons listed. And as part of the solver card enhancements, one of the key enhancements for .3 is to support the set with the Boolean operator. So the set can be defined with subtype and the operator as and, or, not, a minus. So in this case, I want to show a quick demo about how to create a Boolean set. So in this demo, I already have a set which is based out of element set, where I do have associated two sets to it, which is also a similar config of element based set. And you could change the operator option here based on the requirement. Just want to card edit and show how the card looks like. I mean, in this case, I want to highlight one point here. The subtype is mutually exclusive. What I mean to say that, I mean, you could use the Boolean operator as a subtype, or the element can be based out of subtypes, like element could be based out of the property or the material. So the property, material options and the Boolean operators are mutually exclusive. So within the subtype, in this case, it's a Boolean set, you see the Boolean operator here. Now I'm showing how to create a set with a Boolean operator. So in this case, I created a set of grid elements, and then I select the sets option. And you would see that once I go for the selection, I would see the filtered list of nodes, because the base set which I created is a set of grid. So to select the set of grid, I just show only the grid sets alone to be part of the Boolean set. Okay. Some of the key enhancements with regard to the OptiStack solver card or like the rotation option in the tie contact card and other key options here. One respective point to highlight in terms of nonlinear analysis is P-joint G card is enhanced with the damping option, also the constitutive reference option in P-joint G. So these are the key enhancements for .3, and just want to touch base what has been released in .2 as well since .2, but there was no GTS session for OptiStack interface. So just highlighting the key options here. And finally, in .3, we have enhanced the curve editor. So we have a new curve editor in .3, which gives us the advantage to import from a CSV or an export to a CSV based on the XY data what we have in the tabular list. And there is no limitation on the number of rows, which can be copied from the Excel spreadsheet. And we also have a search and filter option. You could either search by ID, or if you could also search by the curve name based on the search filter here. And you could also fit the curve in the graphic area. And you could also dock the curve frame in the browser areas as well. And if you have any questions related to the new curve editor, please feel free to get in touch with me or Sandesh, program manager for Hypergraph. And that's pretty much what I have to share for this session. Thank you for your attention.
Thank you, Raj. Just to introduce myself, I'm Dilip Ram. I'm product manager for solver conversion, ANSYS, Parmas, and Exodus interface. So to begin with, I would like to go over quick updates on solver conversion. I mean, in addition to performance and panel removal, which we did in interfaces, as Raj just mentioned, there were some key enhancements made based on the field requests, which is taken care as part of 2022.3. So before getting to 2022.3, I'll just want to give you a brief introduction to solver conversion. It is basically a one-click solution to convert from one interface to another interface. At the same time, we provide two levels of check on what entities are supported and what is not supported. As you see it on my left hand side, there is one window which basically gives me a list of entities which we support in conversion and at what level we support it. And at the end of conversion, we have a beautiful HTML report, which gives us complete information of what is supported and unsupported. I would like to quickly show the HTML report because this has been asked several times from the field. So I just want to go over the HTML report, which is written post conversion in the documents folder. So it basically gives you a list of entities in the model. So if I go to property, I could see the list of entities or list of cards, which is converted from one interface to another face. I could expand one of them. I could search for that particular property and see if that is listed here. And in addition to what we have here, we also have gone a step ahead to check if that particular card is unsupported or not. I mean, there is still an ongoing effort to improve this, but this is present as part of the HTML report post conversion. Let me move over to the enhancements which we made for solver conversion. The two interfaces which we worked on predominantly from .2 and .3. One is Abacus to OptiStruct and other one is ANSYS to OptiStruct. I mean, I do not want to go over all the enhancements. I have some major enhancements done for Abacus to OptiStruct and ANSYS to OptiStruct. So for this conversion, first thing we took is the theta conversion on nodes. See, in ANSYS, I have the theta specified on the node. So on conversion, I have to create a system mapping to the theta on the node in the ANSYS interface, which was very tedious and cumbersome for the customer. So keeping that in mind, we have supported that in conversion. Let me just quickly run this conversion with major updates which were covered for ANSYS to OptiStruct. Omega is 1. This is in radians per second in ANSYS interface. So on conversion, we take care of the units as well. We convert it to revolutions per second. So as you can see, this is basically an axisymmetric pressure load which is applied on the model. And I would just want to let you know the sensor type which is taken. One is this is a plane 42 element and it is an axisymmetric analysis. So once I convert it to OptiStruct, we convert the pressure load, we convert mat3, theta on the nodes, which is all taken care as part of 2022.2 and 2022.3. So coming to loads, we convert all the axisymmetric pressure to a non-uniform pressure load as it is applied on each edge of that element. And we also convert the omega value with a respect and have also taken care the units with regard to ANSYS to OptiStruct. So just to get the model running to see everything is in place, we also create a load add and map it to the subcase. So moving further. With Abacus to OptiStruct, one major enhancements which we did as in this release is the cohesive material and the elements conversion. So I mean, just to check if I could have a solver runnable deck post conversion. I mean, I've created these boundary conditions and loads mapping to a nonlinear static subcase. So post conversion, you would see a cohesive property, cohesive elements. And to check the credibility of conversion, I just ran a very small, I just exported this converted model, ran it, and we could also post process the result post conversion with no manual work to be done. And one other thing is we match the Abacus result 1-to-1 with regard to this conversion. Okay, moving further, I'll talk about ANSYS interface enhancements made in the previous release. Most of the requests came to support block and unblocked format. With materials, real constants, and loads, we only supported the blocked format. But ANSYS APDL does write out these in the unblocked format, which we were not able to import it earlier. Similarly, we supported the block format for pressure load and the temperature load. So if you see here, my node is in the unblocked format. Element. A constraint CP is in the unblocked format. So if I had imported this in the earlier release, okay, with no support of those blocked and unblocked format, I would not have got any model, but would get a series of warnings. Because we never supported unblocked format for the node. Now, with the latest enhancement in 2022.2, where it was implemented, if I import this model, I get the nodes, I get the CP, I get the temperature, pressure, and everything. So moving further, I mean, as I said, we have supported the block format for the temperature and the pressure load. The BF block for the temperature and SFE block for the pressure. Moving on to the next interface, which is PERMAS interface. We did some migrations. One is it was all contact surfaces earlier. I mean, this is as part of unification across interfaces, and it becomes very easy even from solver conversion or to map these entities across interfaces as well. So as Yuvraj also mentioned, the ConVG card, the thermal migration which is done, it is migrated to a load entity. So even in the Abacus, the star film is in the load entity. So as a roadmap for Abacus to OptiStruct, so I'll have to only map the star film to ConVG, which will be 1-to-1. But earlier I had to create 3 different entities on conversion. One is the group, load, and the property. So this is the whole idea of why we are trying to unify entities across interfaces. So in PERMAS, we migrated the contact surfaces to set segments. This is pretty much similar to what we have done earlier for other interfaces like Abacus, OptiStruct, Dyna, and Radios. And we make sure respective comments are written out so that we retain the name, color, and the ID. And one last thing which I would want to talk is PERMAS. In groups, all the entities which were taking me to panel is removed and is taken care as in the context for all the group. Thank you. This is all I had for this release.